Comparing fractions with different denominators. We have learned about representing fractions in words, symbols, as pictures, knowing that rectangles are the most useful picture, and on number lines. Now we will look at comparing fractions using equivalent fractions. Here we have 3/4 and 1/2, which is larger. 3/4 is 3 of 4 equal parts, and 1/2 is 1 of 2 equal parts. 3/4 as a picture looks like this, and 1/2 looks like this. We can now see which is larger, but we'll use equivalent fractions to be certain. One is 4 equal parts and the other is 2. We need to think about how the denominators might be related to use equivalent fractions. We know that 2 times 2 is 4. This means that 2, 2 and 4 are a number family. So we can make both fractions have a denominator of 4. To do this, we can divide the half into 2 equal parts to make quarters. Notice we don't change the value of the fraction, just what it looks like. So we have proved that 1/2 is the same as 2 of 4 equal parts, or 2/4. Now we can be certain that 3/4 is larger. We also know it is larger by a quarter. We can look at this on a number line. We mark in 1/2 in the middle there, 1/4 is there, 2/4 is the same point as 1/2, and 3/4 is there. So 3/4 is larger than 1/2. Let's look at another example. Here we have 7/12 and 2/3, which is larger. We know 7/12 is 7 of 12 equal parts, and 2/3 is 2 of 3 equal parts. We can draw them as rectangles. Then, because one is out of 12 equal parts and the other 3, we need to think of the relationship of the denominators, their number family. We know 3 times 4 is 12, so we can change thirds into an equivalent fraction of 12ths by multiplying by 4. We do this by making each of the thirds 4 equal parts like this. We can now see that 2/3 is the same as 8 of 12 equal parts, so 2/3 is larger than 7/12. We can again look at this on a number line. This one is divided into 12ths. We count along and 7/12 is there, and with thirds every fourth line will show thirds, because 3 lots of 4 makes 12. So 2/3 ends up being there. We know this is 8/12, and it is larger than 7/12 by 1 more 12th. There are lots of fractions, so let's look at another example. Here we have 60 hundredths and 3/5. 60 of 100 equal parts and 3 of 5 equal parts. They look like this as pictures. Again, we need to think of equivalent fractions because they have different number of parts. We need to think about how 100 and 5 are related. It can be a bit tricky, but if we think really carefully, we can work out that 5 lots of 20 equals 100. So we can multiply our fifths diagram by 20 to get hundredths. When we add the lines in to show this, you can see each of the fifths becomes 20 equal parts to make 100 equal parts altogether. The shaded part is 3 lots of 20. This means that it's 60 equal parts out of 100. This means the fractions are the same value. You can see we don't change the fraction, we just add extra detail to show its equivalent fraction. Let's try one showing the numbers more clearly on the picture to see if we can eventually complete the problems without drawing a picture. Here we have 9 of 12 equal parts and 3 of 4 equal parts. We know they have different denominators, so we need to think of their relationship. 3 lots of 4 is 12, so we can change the quarters to be 12ths by multiplying by 3. Let's think about 3/4 and draw the diagram. To multiply each of the quarters by 3, we need to add lines like this. So each of the 4 quarters is now 3 equal parts to make 12ths. To represent the equivalent fraction, we can see the shaded part is now 3 lots of 3 to make 9. And the whole is now 3 lots of 4 to make 12. So 3 quarters is equivalent to 9 twelfths. Therefore, 9 twelfths and 3 quarters are the same. When working with fractions, it is important to be able to think of number families so we can think about their equivalent fractions and work with them more easily.